lesson 27, April the 12th to the 16th. We're back from spring break. Hopefully you guys had a good week. We're going to be looking at the sine and cosine of complementary angles and special angles. In the last lesson, I introduced you to sine, cosine, and tangent. Alright? So we're just going to continue looking at some of those things. Alright? So our goals in this lesson is to understand that we have measurements of complementary angles. We're going to figure out what the sine of A would equal the cosine of B. Alright? So we've kind of talked about this a little bit, but now we're actually going to discover this. Alright, so let's look at this. If A and B are the measures of complementary angles, then we are going to show that the sine of A is equal to the cosine of B. In right triangle ABC, the measurement of acute angle A is denoted by A, and the measurement of the acute angle B is denoted by B. Determine the following values in the table. Alright, so sine of A, if you remember this right here, I told you if you could remember this, then you could remember sine, cosine, tangent. SOHCAHTOA. Sine is the opposite, so I'm looking at the opposite of A, which is A, over my hypotenuse, which is C. So the sine of A would be A over C. Let's look at the sine of B. Alright, so the sine of B is opposite, which is B, over hypotenuse, which is C. Alright, look at cosine of A. Cosine is the adjacent, so B over hypotenuse doesn't change. Alright, and then cosine of B is the adjacent, alright, which would be A over hypotenuse, which is C. Alright, so it says, what can you conclude from the results? Well, look at this. Since the sine of A is the same as the cosine of B, then I can conclude that they're equal. So since the sine of A and cosine of B are the same, we can say that the sine of A is equal to the cosine of B. Alright? So then kind of flip it. What do I notice about the sine of B and the cosine of A? Well, I see that they are the same. We can also say that the cosine of A is equal to the sine of B. Alright? So the sine of an angle is equal to the cosine of its complementary angle. Now guys, complementary means 90 degrees. In a right angle, I know that my two angles have to be complementary. Alright, which means they have to equal 90 degrees. That doesn't mean that they have to be 45 degrees. They could be anything that adds up to 90. Alright, but this is what I know. Alright? Alright, so exercises 1 through 3. Consider the right triangle ABC so that angle C is a right angle and the degree measures of angle A and angle B are A and B, respectively. So find A plus B. Alright? Well, since they're complementary, because I know that this is a 90-degree angle and this is a right triangle, so 180 minus 90 is 90, I know that A plus B must equal 90 degrees. Alright, must. Use trigonometric ratios to describe BC over AB two different ways. Alright, well, so BC, let's look in reference to angle A. BC is my opposite, and AB is my hypotenuse. So opposite over hypotenuse is sine. So we can say that's the sine of A. Alright. And we've already proven that the sine of A is the same as the cosine of angle B. So I can describe this two different ways. I can describe it as the sine of A, or I can describe it as the cosine of angle B. Alright? Use trigonometric ratios to describe AC over AB in two ways. So I've got AC. So if I'm looking in reference to angle A, AC is my adjacent. Alright? And AB is my hypotenuse. So an A adjacent over hypotenuse would be the cosine of A. So we can say this is the cosine of A. And we have proven that the cosine of A is also equal to the sine of B. Alright? Alright? What can you conclude about the sine of A and the cosine of B? Well, we can conclude that the sine of A is equal to the cosine of B. Alright? What can you conclude about the cosine of A and the sine of B? We can conclude the cosine of A is equal to the sine of B. Alright? Find the values for the angle that make each statement true. Alright? So I want to know the sine of my angle if the cosine is 25. Well, guys, what do we know? They have to be complementary, which means 90 minus 25 gives me 65. So the angle must equal 65. If the sine of 80 is equal to the cosine of an angle, once again, 90 minus 80, so that's 10. So the angle must equal 10. Alright? The cosine or the sine of an angle if the cosine of the angle plus 10. Alright? Here I can think about this. Okay, so x plus 10. So I have x and x plus 10. So my sine of my angle is x, and then cosine is x plus 10.
Can I have your attention, please? Need the following students to the office, please. Emma Adamson,
That
Sarah
must
Gifford,
equal 90.
Carly Church, and Kimmy Wood. Again, following students to the office, please. Emma Adamson,
Alright,
Sarah Gifford, Carly Church, and Kimmy
Solve
Wood.
it.
Thank you.
so 2x plus 10 is equal to 90. Subtract. 2x is equal to 80, which means that my angle must equal 40. Alright, so here I've got the cosine of an angle, so we'll let that equal x. And then I have that angle minus 45 is equal to 90. So 2x is equal to, I'm going to take that 45 over 135, divide by 2. My angle must equal 67 and a half. Alright? For what angle measurements must sine and cosine have the same value? Explain how you know. Sine and cosine would have the same value if the angle were 45 degrees. Alright? That's the only way that sine and cosine would have the same value. If my angle equaled 45 degrees. Alright? The sine of an angle is equal to the cosine of its complement, and since the complement of 45 is 45, then I would know that the sine of 45 is equal to the cosine of 45. Alright? So the sine of an angle is equal to its complement. Make sure you can see my paper here. Okay? To its equal to its complement. I forgot to put its cosine. Alright? So the complement of 45 is 45. So I know the sine of a 45 degree angle would be equal to the cosine of a 45 degree angle. Alright? Alright. So we're going to start looking at special angles that are associated with sine and cosine. Alright? We're going to be looking at angle measurements of from 0 to 90 degrees. Alright? What is happening to A and B as 0 changes? What happens to the sine of the angle and the cosine of the angle? Alright. So, what's happening to A as B, or what happens to A and B as my angle changes? Alright, so let's think about this for just a second. There are values for sine and cosine commonly known for certain angle measurements. Two such angle measurements are when the angle is 0 degrees and when the angle is 90 degrees. To better understand the sine and cosine values, imagine a right triangle whose hypotenuse has a fixed length of 1 unit. Alright? What happens to the value of the sine ratio as the angle approaches 0? Consider what's happening to the opposite side, A. Alright, so let's think about this for just a second. I want to know what is happening to A as my angle changes. Well, as my angle changes, that means this side is changing. Alright? And so A is what's happening to A. As your angle approaches 0, my side is decreasing. Alright? So since the sine of my angle is A over 1, the value of sine is also approaching 0. Alright? So, let's talk about as my angle approaches 0. Alright? And I know my angle is approaching 0. If I'm closing that angle, this angle right here is getting smaller and smaller. A decreases. It gets smaller. Alright? So since the sine of my angle is A over 1, then that value is approaching 0. Okay? So then let's talk about what happens to B. As my angle closes, notice what happens. Okay, so here's my finger, and my finger is at the end of A. As I close this angle, notice the tip of my line is moving out here. So B is actually increasing. So as my angle approaches 0, B increases. All right, it has to get longer in order to get to that tip of A. All right, and it comes closer to 1. All right. All right. So since the cosine of the angle is b over 1, the value of cosine is getting closer to 1. It approaches 1. All right. Now let's talk about what happens as it approaches 90 degrees. All right, which means now my angle is going to open up. All right. So as my angle, so here we go. We're going to put our finger here. As that angle opens up, what happens to A? A has to increase in order to accommodate that bigger angle. A increases. All right, so A is increasing and getting closer to 1. All right, so since the sine of the angle is A over 1, the sine is also approaching 1. Now let's talk about B in respect to as it approaches 90. So here is my B. If A is getting longer and that angle is opening up, what's happening to B? B is going to decrease. So as the angle approaches 90, B decreases. All right? B is decreasing and it's getting closer to 0. All right? So since the cosine of the angle is equal to b over 1, the value of the cosine is approaching 0. Okay? Now I kind of ran out of room there. Okay, because there are no right triangles with an acute angle of 0 or 90, In the above thought experiment, we are defining sine of 0 as 0 and the cosine of 0 as 1. We also define the sine of 90 as 1 and the cosine of 90 as 0. Notice that this falls in line with our conclusion that the sine of an angle is equal to the cosine of its complementary angle. Alright, so up here, I'm just going to make a note of that. The sine of 0 is 0. The cosine of 0 is 1. And then the sine of a 90-degree angle is 1. And the cosine of a 90-degree angle is 0. Alright? Now, you're not going to see that, but just have an idea of what's happening. Alright, there are certain special angles where it is possible to give the exact value of sine and cosine. These are the angles that measure 0, 30, 45, 60, and 90. These angle measures are frequently seen. You should memorize the sine and cosine of these angles with quick recall, just as you did your arithmetic facts. Learn the following sine and cosine values of the key angle measurements. Alright? So the sine of 0 degrees is 0. The sine of 30 is 1/2. The sine of 45-degree angle is the square root of 2 over 2. 60-degree angle is the square root of 3 over 2. And the 90-degree angle is 1. Cosine of a 0 degree is 1. 30 degrees is square root of 3 over 2. 45 degrees is square root of 2 over 2. 60 degrees is 1/2. And 90 degrees is 0. We focus on an easy way to remember the entries in this table. What do you notice about the table values? Well, hopefully you notice that the entries for cosine are the same as the entries for sine, but they are in reverse order. So 0, 1/2, look, they just go backwards. This is easily explained because the pairs 0, 90, 30, 60, and 45, 45 are the measures of complementary angles. So for instance, the sine of 30 is equal to the cosine of 60. The sequence 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1 may be easier to remember as the sequence the square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and the square root of 4 over 2. Okay? In triangle ABC is equilateral with side lengths 2. D is the midpoint of side AC. Label all side lengths and angle measurements for triangle ABD. Use your figure to determine the sine and cosine of 30 and 60. Okay. So I would suggest that we construct the angle bisector of angle B, which is also the altitude of AC. Alright? So if I do an angle bisector of angle B, that means it divides angle B into 2 equal parts, correct? Okay. With it being an altitude to AC, that also means that I create 90-degree angles. So we're not going to go through the actual construction of this, but I'm going to draw the altitude of my triangle here. Now, with that being said, all 3 sides measure 2. With this being an altitude, what happens here? I'm dividing that into 2 equal parts. Alright? That means that this creates a right angle. If all 3 angles have to be equal, because this is an equilateral triangle, all 3 sides are equal, all 3 angles are equal, which means that all 3 angles equal 60 degrees. If I split this one as an angle bisector, I would divide that into half, which means this angle is 30 degrees. Alright? So, let's talk about finding the length of this, because that's really the only other thing that I need to find the length of. Alright? Because whatever this side is, this side is going to be the same thing. So, the sine of my 30-degree angle, alright, sine is opposite. So, opposite, which is 1, over my hypotenuse, which is 2. Alright? Sorry, we have to take a step back for just a second. And we've got to figure out the measure of this third side of my triangle before I can actually get into the sine and the cosine of my angles. This is a right triangle, so how do I find the missing side of a right triangle? A squared plus b squared is equal to c squared. Alright, so a squared will be 1. I don't know what b is, and then c squared is 2. So 1 plus b squared is equal to 4. Subtract, I get b squared is equal to 3. Take the square root of that, so b is equal to the square root of 3. Alright, so here I now know what that side measure is. Alright, let's find the cosine of my 30-degree angle. That is the adjacent, so that would be the square root of 3 over my hypotenuse, which is 2. Alright, now I'm going to find the sine of my 60-degree angle. Alright, so sine is opposite, so square root of 3 over hypotenuse, which is 2. And cosine of my 60-degree. Alright, cosine is adjacent, so that'd be 1 over 2. Alright? Draw an isosceles right triangle with legs of length of 1. What are the measures of the acute angles of the triangle? What is the length of the hypotenuse? Use your triangle to determine sine and cosine of the acute angles. Alright? Well, so part B helped demonstrate how the sine and cosine values of special angles can be found. Alright? So if you look, we said a 30 or a 60. So the sine of a 30-degree angle was 1/2. Looking back on that chart, look, the sine is 1/2. Cosine of a 30 was square root of 3 over 2. Look what we got. Alright? So these triangles are common in trig. So let's look at this. If this is an isosceles triangle, then I know that 2 sides are equal, and those 2 sides also, since it's an isosceles triangle, those 2 sides are equal. I know that the base angles have to be equal. So if this is a right triangle, this is 90 degrees, these 2 angles have to be equal, which means that they are both 45 degrees. Alright? So my angles are 45 degrees here. This is a 45, 45, 90 triangle. So I can now look at the sine and cosine. I don't really even have to do much. I could look back on my chart, or I can look at the sine of a 45 degree. Alright, sine is opposite. So, here we go. Once again, I kind of jumped ahead of myself. What do I have to figure out? I need to figure out my hypotenuse. So a squared plus b squared is equal to c squared. So 1 squared plus 1 squared is equal to c squared. 1 plus 1 is equal to c squared. 2 is equal to c squared. Square root of 2 is equal to c. So my hypotenuse is the square root of 2. Alright, now I can do the sine of my 45 degree angle. Sine is opposite, and guys, it doesn't matter which one you use. Opposite is 1 over the hypotenuse, which is the square root of 2. Alright, and the cosine of a 45 degree angle, which is adjacent, gee, imagine that, and over the square root of 2. Notice my sine and my cosine are the same. What did we say? We said sine and cosine would be equal if they were 45 degree angles, if both angles were 45 degree angles, which we just proved that. Alright? Alright, so parts B and C demonstrate how the sine and cosine values of the mentioned special angles can be found. These triangles are common in trigonometry. We refer to the triangle in part B as a 30, 60, 90 triangle, and the triangle in part C as a 45, 45, 90 triangle. Alright, so look, they have now given us the ratios. Alright, the 30, 60, 90 triangle side lengths of ratio 1, 2, and square root of 3. So they're saying, okay, I can multiply this by 2, and when I multiply one side by 2, I multiply all sides by 2. Alright? So then I would get a 2, 4, and 2 square root of 3. Here they're multiplying by 3. Here they're multiplying by 4. Here they're multiplying by x. Alright, so in a 30, 60, 90 triangle, I can multiply everything here and get another triangle, but it would still be a 30, 60, 90 triangle. 45, 45, 90 triangle with a side lengths ratio of 1 to 1 to square root of 2. Once again, I can multiply, and notice what I get. 2, 2, 2 square root of 2. Alright? So, guys, these are going to become pretty important. Hopefully you can use these and can memorize these and, use them in the future. Alright? Exercise 4 and 5. Last 2 questions. Find the missing side length of the triangle. Alright. So I have the sine, or I have a 30-degree angle. Alright, so I can go back and I can look and see that the sine of a 30-degree angle is 1/2. Alright? So here, the sine of my 30, my opposite is A, over my hypotenuse, which is 3. I can say that is equal to 1/2, and now I have a ratio. So I get 2A is equal to 3. Divide by 2, so A would be 3/2. Alright? Then I can use the cosine of my 30-degree angle. So cosine is the adjacent, so that would be B over hypotenuse. And we said a cosine, if you go back to your table, the cosine of a 30-degree angle is the square root of 3 over 2. Alright? So multiply, I get 2b is equal to 3 square root of 3. Divide by 2, b would be equal to 3 square root of 3 over 2. Alright, find the missing side lengths of the triangle. Once again, I'm doing a 30. Alright. In this case, I have my adjacent. I've got to figure out my hypotenuse and my opposite. So I would suggest, since I know my adjacent, adjacent deals with the cosine. So I'm going to do the cosine of a 30. Alright, cosine of a 30 is adjacent. 3 over hypotenuse, which is c. Alright, we said the cosine of a 30 is the square root of 3 over 2. Alright, so I get the square root of 3c is equal to 6. Alright, so divide by the square root of 3. C is equal to 6 square root of 3. Guys, I cannot, when I'm dealing with measurements, I don't want to leave that radical. So I'm going to multiply times the square root of 3. So I get 6 square root of 3 over 3. I can reduce this to 2 square root of 3. Alright, now that I know my hypotenuse, now I can do the sine of a 30-degree angle. Alright, so the sine of a 30-degree angle is the opposite, A, over my hypotenuse, which is 2 square root of 3. Alright. Nope, sorry. Messed that up. No, that's right. A over 2 square root of 3, I've got that, is equal to the sine of a 30 was 1/2. Alright, so I get cross multiply. 2a is equal to 2 square root of 3. Divide by 2. 2 divided by 2 is 1, so a is equal to the square root of 3. Alright? Guys, I cannot stress enough how important it is to memorize this table. Alright? Memorize that table, highlight it, put a star beside it. That's an important table, and then this is important. Alright? Guys, have a great rest of the day, and I'll talk to you later.